Have you ever stopped to think about the invisible structures holding up our digital lives? Today, we're diving into the story of someone whose, well, quiet determination completely reshaped how data works for all of us.
That's a fascinating story. Imagine this seemingly quiet figure, right, whose sheer intellectual stubbornness, you could say, ended up transforming, well, everything. We're
Yeah.
talking about Edgar F.
Exactly, Edgar F.
Yeah.
And it's more than just, a technical history lesson.
Oh, absolutely.
Yeah.
It's about how this huge shift in thinking about data, something born from really deep theoretical work, became this unseen foundation for pretty much
Right.
everything we do online now. Searching, shopping, enterprise systems, it's all built on it.
Right. So our mission today is a proper deep dive into the life and work of Cod. He's the British computer scientist, widely credited as the pioneer of the relational database model.
And we want to go beyond just a list of dates and achievements.
Yes. We'll explore his whole journey. From his early days, his really groundbreaking stuff at IBM, the significant pushback he got trying to get his ideas accepted.
Which was considerable.
It really was. And ultimately, how his persistent belief, this conviction in a totally new way to organize data, laid the groundwork for, well, almost every app, website, digital service you use daily. It's the human story behind a tech revolution.
Okay, so where do we start? The beginning.
Let's do it. Fortune's Well, on the Isle of Portland, Dorset, England. That's where Edgar Frank Codd was born, August 19th, 1923.
And his early path wasn't straight into computing, was it?
Not at all. He went to Exeter College, Oxford, studied mathematics and chemistry. A brilliant guy, obviously, but not the background you'd immediately peg for the architect of modern databases.
It's a great example of how different paths lead to innovation. And there's another layer, too, his wartime service.
Right. World War II. He was a pilot in the Royal Air Force Coastal Command, flying Sunderlands, these huge flying boats.
Quite a contrast to his later life, sitting and thinking about data structures. It hints at maybe a disciplined, practical side.
A very different kind of structure, I suppose. So the war ends, and then what?
Well, not long after, 1948, he makes a big move, crosses the Atlantic to New York, joins IBM.
As a mathematical programmer, what did that even involve back then?
Well, early days.
Mhm.
He worked on projects like the Selective Sequence Electronic Calculator, the SSEC, one of the first really big electronic computers.
Wow.
Yeah, and he was also involved in developing the IBM 701 and 702. These were some of IBM's first commercial computers, the ones that actually stored programs. So he was there, right at the beginning of that era.
Laying the groundwork. But wasn't there a brief departure from IBM around then?
There was, yeah. It gives a little glimpse into his character, I think. Around 1953, he actually moved to Ottawa, Canada for a bit.
Why was that?
Reports suggest he was, and this is the quote, dismayed by Senator Joseph McCarthy, the whole political climate in the U.S. at the time.
Ah, right. So a man of principle, even early on.
Seems like it. It kind of foreshadows his later willingness to stand his ground, doesn't it? Anyway, he came back to IBM in the U.S. in 1957.
And after returning, he makes this significant academic shift.
Yeah, he decides to pursue a PhD. From 61 to 65, he's at the University of Michigan in Ann Arbor, studying computer science.
And his thesis wasn't exactly light reading, I gather?
No, not at all. It was titled Propagation, Computation, and Construction in Two-Dimensional Cellular Spaces, basically exploring self-replication in cellular automata.
Okay, hold on. Cellular automata. Break that down a bit.
Sure. Think of like a grid. Each square or cell has a state, maybe on or off, or a color. And the state of each cell changes based on the states of its neighbors, following simple rules.
Right, like Conway's Game of Life, maybe?
Exactly like that, yeah. It's a way to model complex systems. Cod built on earlier work by von Neumann, and his thesis showed something quite remarkable, that you only needed 8 states per cell to achieve universal computation and construction. Basically, a self-replicating computer.
A self-replicating computer in the early 60s.
Yeah. And his specific design was so advanced, so theoretical, it wasn't actually built, implemented, until 2010.
Wow. Decades ahead of his time.
Absolutely. Shows the depth of his thinking.
Okay, so PhD done. Then what?
Then, in 1967, he moves to IBM's San Jose Research Laboratory in California. And this is really where the magic happens, where he stays until the 1980s and does his most famous work.
This brings us to the big one, the relational model.
A relational model, yes.
Yeah.
So throughout the late 60s and into the 70s, Codd is meticulously working out his theories on how data should be arranged.
What was the problem he was trying to solve? What was data like before Cod?
Well, data was typically stored in these quite rigid structures, hierarchical like an org chart or network models. It made it really difficult to ask new questions of the data or combine information from different places. You were locked into predefined paths.
Okay, I see. Inflexible.
Very. Then comes Codd's breakthrough paper in 1970, a relational model of data for large shared data banks. It followed an internal IBM paper the year before.
And the core idea was,
Radically simple, in hindsight. Organize data into tables relations, he called them. Just rows and columns, like spreadsheets almost. But these tables were independent, and you could link them using common data fields.
so instead of fixed paths, you could link things dynamically.
Exactly. It made data flexible, easily queryable using mathematical principles, actually, and crucially, independent of the specific applications using it. That was the paradigm shift. You could change the application without restructuring the entire database.
Sounds brilliant. Elegant, even. So IBM jumped right on it, right?
Well, no, not exactly. This is where the story gets interesting. Codd faced, quote, disappointment because IBM was actually slow to exploit his suggestions.
Oh, it sounds revolutionary.
It was. But think about it from IBM's perspective in the early 70s. They had an existing, very profitable database system called IMSDB.
The hierarchical one.
Yeah, the hierarchical model. It
Yeah.
was making them a lot of money. Codd's relational model, elegant as it was, directly threatened that revenue stream.
Ah, the classic innovator's dilemma. Protecting the current business hinders the next big thing.
Precisely. IBM's focus on protecting IMS meant they kind of fumbled the future of databases, which their own researcher had just invented.
But Codd didn't just give up, did he? He sounds pretty stubborn.
He was. He started showing IBM's customers what his relational model could do.
Oh, clever. Going around the internal roadblocks.
Kind of. And those customers started putting pressure on IBM. Hey, what about this relational thing Codd is talking about?
So IBM had to react.
They did. They launched the sub-project called System R under their big Future Systems initiative to explore relational ideas. But, and this is crucial,
There's a catch.
there's a catch. IBM management deliberately put developers in charge who were, let's say, not thoroughly familiar with Codd's ideas, and they actively isolated the team from Codd.
Seriously, they sidelined the inventor.
Pretty much the result. That team developed a query language called SQL, Structured English Query Language, which later got shortened to SQL.
SQL, the language basically everyone uses with databases today.
The very same. But it wasn't the language Codd himself had envisioned or preferred. He designed a more mathematically pure language called Alpha.
So SQL was kind of a pragmatic compromise, maybe driven by people who didn't fully grasp Codd's deeper concepts.
You could argue that. And here's another twist. Before IBM could even get its own product using SQL, which became SQL DS, to market.
Someone else beat them to it.
Yep. A guy named Larry Ellison attended some conferences, saw pre-launch papers about System R and SQL.
No way.
Guess what? He basically took the concepts and rushed out his own version. That company became Oracle, and Oracle Database hit the market in 1979 before IBM's own offering.
Wow. IBM invents it, fumbles it, and Oracle swoops in. That's quite a story.
Yeah.
And underscores Codd's influence, even indirectly.
Absolutely. It shows how powerful the core idea was.
So despite these battles, Codd kept working on the model itself.
Oh, definitely. He was relentless. He continued developing and extending the relational model, often collaborating with Christopher J. Date, another big name in the field.
We see his name on things like the Boyce-Codd normal form.
Right, BCNF. That's a key principle in database design about minimizing redundancy and improving data integrity. It's named after him and Raymond Boyce. And there's Codd's theorem, too, which related the expressive power of relational algebra and relational calculus. Deep stuff, but fundamental.
And he wasn't shy about defending his creation either, was he?
Not at all. As relational databases started becoming popular in the early 80s, lots of vendors were jumping on the bandwagon. Some were just putting a thin relational veneer, as he called it, on top of their old hierarchical or network system.
Trying to cash in on the buzzword without doing the real work.
Exactly. And Codd was furious. He launched what was described as a sometimes bitter campaign to define what truly constituted a relational database.
Is that where his famous 12 rules came from?
That's it, precisely. He published these 12 rules, technically 13, counting Rule 0, that laid out strict criteria for a database management system to be considered fully relational. It was his way of protecting the integrity of his invention.
That kind of purist stance must have caused friction back at IBM.
It certainly did. His position became increasingly difficult. Eventually, he left IBM and formed a consulting company with Chris Date and some others,
Still pushing the boundaries, though.
always. Later on, he also coined the term OLAP, online analytical processing. That's about analyzing large amounts of data from multiple perspectives, kind of the foundation for a modern business intelligence.
It's another foundational idea.
Yep. He even came up with 12 laws for online analytical processing, though there was a bit of controversy later about undisclosed sponsorship for that specific paper.
Ah, how did that play out?
Well, apparently once Codd became aware that the vendor sponsorship hadn't been disclosed, he insisted it be made public, which, kind of fits his character
Yeah.
demanding that intellectual honesty.
Despite all the struggles, the resistance, his impact was eventually recognized, right?
Oh, hugely. He was made an IBM fellow back in 1976, which is a big deal within IBM. But the really major one was the Turing Award in 1981.
A Nobel Prize of Computing.
Basically, yes. The citation was for his fundamental and continuing contributions to the theory and practice of database management systems. Very well deserved. He also became a fellow of the ACM, the Association for Computing Machinery, in 1994.
A towering figure in the field by then.
Undeniably. Sadly, his health started to decline in the 1990s, and he had to stop working. Edgar F. Codd passed away from heart failure at his home in Florida on April 18, 2003. He was 79.
And the world remembered him.
It did. Just a year after his death, SIGMIDES, that's the main academic conference for data management, renamed its highest award. It became the SIGMID Edgar F. Codd Innovations Award, a fitting tribute.
So as we wrap this up, it's quite a journey to reflect on. You have this quiet mathematician, a former WWII pilot, who becomes this absolute visionary in computer science.
Yeah, and that personality comes through quiet, maybe understated personally, but incredibly stubborn intellectually. Avoided the limelight, apparently, but just would not back down on his ideas, even against IBM.
That unwavering conviction is key.
It really is. And if you step back and look at the big picture, his theoretical work, the stuff IBM initially resisted, it truly became the bedrock. It's how we structure and access data pretty much everywhere now. Online shopping, banking, scientific research, social media.
It all relies on relational principles, fundamentally. He didn't just invent a product, he invented a new way to think about information.
He really enabled the information age as we experience it. That flexibility, that power to query vast amounts of data that comes from Codd.
So here's a final thought for you listening. Think about how many of these absolutely critical innovations, the deep foundations of our digital world, didn't come from market research or, flashy product launches.
They came from quiet, persistent, maybe even stubborn individuals like Codd, pursuing elegant theoretical solutions.
It makes you wonder, doesn't it? What other unseen architectures are being quietly built right now by people thinking deeply, maybe facing resistance, that will define our digital future?